Hi, this question says a particle having mass m and charge q is projected at an angle of 75 degree to the horizontal with a speed u. A uniform electric field E is equal to mg by q exists in horizontal direction. Find the time after projection when the velocity of particle makes an angle of 45 degree with horizontal. So, which are the forces acting on this particle? So, one is of course the gravitational force mg, and other is the electric force because of the field E is equal to mg by q, which will be in the direction of horizontal direction, which the direction which field has. So mg by q into QE is the force, electric force, so it will be QE is q into mg by q, which is also mg, and the gravitational force is mg. So you have mg and mg working in a typical 90 degree angle scenario. So the resultant would be mg root 2, okay, in the 45 degree direction from horizontal or vertical, whichever. So because both the vectors are same, the quantity is same, the magnitude is same, and the direction would be 45 degree, and amplitude will be mg root 2. Right, now we will visualize the motion of the particle. Particle is moving at an angle of 75 degree with the horizontal, and the expectation is that after some time the particle makes an angle of 45 degree with the horizontal. That means particle shifts around 30 degree towards horizontal direction, correct? So now we are drawing the motion of the particle, the trajectory of the particle. So in a typical projectile, what happens? The particle has two velocities. One is the vertical velocity, other is the horizontal velocity. So one way of doing it was in typical XY reference frame, but instead we have chosen to do it in a different XY reference frame, wherein we will take X at 45 degree from horizontal, and obviously Y will be at 90 degree from X. So then from the new X it will be 90 degree and 45 degree from the original x-axis, because it's already 45 degree tilted towards y. Okay, so in the new xy reference frame we will review this. Okay, so the particle was going at 75 degree before, and then it is expected to come to 45 degree from horizontal. So that 45 degree from horizontal we are taking as the new x-axis. Now we know that we have our force vector, which is also at 45 degree from the original x-axis. That means it is at 90 degree from the new x-axis, so that we can say is the new y-axis. So we have g root 2 deceleration happening in the y direction, and in the new x direction the velocity component becomes u cos 30, and vertical velocity component becomes u sin 30. So now can we rephrase the question as if the particle was moving at 30 degrees angle from ground and with the velocity u, and it is supposed to come to a point where the vertical velocity becomes 0, because that is when the horizontal velocity becomes u cos 30, which is in that 45 degree direction from the original x-axis, which is what we were expecting the particle to follow. So if we see the retarding forces or retarding acceleration is g root 2, and the initial velocity is u sin 30 in the new xy reference frame. I am talking of y-axis velocity. So we will use the formula v is equal to u plus 80. So v becomes 0 in vertical y-axis reference frame, the new y-axis. Okay, and so this is u sin 30 minus g root 2 into t, right? And sin 30 is 1 by 2. So it becomes u sin 30 is equal to g root 2 t. So t is equal to u sin 30 by g root 2. and sin 30 is 1 by 2. So answer is u by 2 root 2 g. Thanks.